Hi there. I just wanted to give some general feedback on Quiz 8. I really haven't had time to look at them yet, and I'm going to focus pretty much the rest of the time between now and tomorrow's class on grading the exams. And so I'm probably not going to be able to come back and give you individual specific feedback on Quiz 8, but I did want to post a short video that just kind of walks through the general idea of what Quiz 8 is about so that if you are struggling with it or if you turn something in and you're not sure if it's correct, this gives you kind of an idea of a way to think about it. So if you watch this, as you work on this, you are welcome to submit revisions before I give you individual feedback, just because it might be a day or two before I get around to giving you individual feedback on Quiz 8. But you're welcome to submit revisions before then. I will grade the most recent submission or evaluate the most recent submission and give you feedback on that when I eventually get to the feedback portion of the quiz. All right. So when we look at this quiz question, right, there's a couple of things going on. We're given an estimated number of steps, right? We're given a number of carbons in our starting material and a number of carbons in our product. And so kind of as we think about this, we're going to work from both directions. We're going to take the information that we're given, and this is kind of how do we start to think about this? Because it's not obvious maybe what the first thing we should do is. So usually what I do with a synthesis question is I make a mental list, although you can also write it down, and just kind of make a list of things that I need to accomplish, right? Things to do in this synthesis. And so I think the first thing is we have 6 carbons on the left, we have 9 carbons on the right, right? And so the first thing that I need to accomplish, or maybe not I shouldn't say first thing, but one of the things I need to accomplish is I need to add 3 carbons. And so as I go through my 5 steps, at some point I'm going to have to go from 6 carbons in my starting material to 9 carbons in my product. Right? The other thing um, that's changing going from the starting material to the product is that I'm also going to make 2 aldehydes, and that's kind of weird, right? We haven't done a lot of reactions that end up making 2 aldehydes. And so that's worth noting and definitely something that we want to put on our to-do list when we are doing this synthesis. All right, so how do we take this to-do list then and actually start turning it into actual steps? So the first thing to do is just kind of look at each one of these and consider them by themselves. So what reactions do I know? Reactions that add carbons. Right? Reactions I know that add carbons, I'm thinking about, okay, I want to connect things together. I have 6 carbons, I want to connect it to 3 other carbons. When we connect things, that's almost always making a sigma bond, right? That's the sigma bonds are the things that connect atoms to other atoms. And so when we talk about adding carbons, what I really mean is I need to make a sigma bond. All right, so making sigma bonds, we have a couple of ways that we do that. One is addition reactions, but the most common way that we make sigma bonds is through substitution reactions. And so as soon as I see that I'm adding carbons to a structure, right, making a sigma bond to do that, I start to think about, is this going to be an SN1 or SN2 process, right? SN1 or SN2. And the nice thing is that in both cases, the thing that I need to have for a substitution reaction is I need a nucleophile and I need a leaving group. So now I know that as I go through these steps of this synthesis, I'm looking for what is my nucleophile going to be? What is my leaving group going to be? What should I try and make that will fulfill these roles, right? So we're going to put that down. I'm going to write it down, but I'm not going to do anything with it exactly just yet. I just know that somewhere in this synthesis, I need to do this. Okay? All right, and then the second thing, right? The second thing in here is I want to make aldehydes. So how do I make 2 aldehydes? Well, we have lists of reactions that we've covered in this class. We've covered a lot of them, but we only have one that makes two products, and both of those products are carbon-oxygen double bonds like aldehydes are, right? And so when we do this, so hopefully, as you've thought about this, we go back and we find ozonolysis as the most likely reaction that's going to create aldehydes for us, right? We've done other reactions that create a single aldehyde, right? If we talk about hydroboration of an alkyne, but to make two aldehydes like this, especially two aldehydes that are separate compounds, ozonolysis really fits the bill. And so an ozonolysis is always an alkene, right? With ozone as my first reaction, dimethyl sulfide as my second step, and that gives me, right, two carbonyls. Okay. And so now when I recognize this, so we made our list of things to do, just observing the differences between starting materials and products. We made our list of things to do, and then what we want to do is we want to take that list of things and start associating that with reactions, right? So we have a choice. We can start to work on either the SN1, SN2, or we can work on the ozonolysis. I'm going to choose to work on the ozonolysis because I think that that is a better choice. And so I'm going to look at my products, which look like this, and think about, so if I know I'm doing ozonolysis to make these products, the box that I want to fill in, right, is what does my starting material look like? And we've definitely answered questions like this before. This is where we get into what types of strategies do we use for these things. The best one with ozonolysis is to number your carbons, start labeling your carbons, because it'll become very clear kind of what we need to do, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So I have 9 total carbons as we've already established. And remember with ozonolysis, what happens is we break the double bond, and the carbons where the double bond was connected, that's where we put our oxygens. And so what I want is I want to connect carbon 7 to carbon 9 with a pi bond. So I can draw that structure. I have 1, 2, 3, 4, 5, 6. I have carbon 7 down here. So all of this, all my carbons stay the same. Here's carbon 7, and then I'm going to go to carbon 9 right here, and I'll put a double bond in between them. Right? So I just put 8 and 9 over here. I connect these with this. This is the structure that I want. If I can make this thing, I can do ozonolysis with it and make my final product, right? So we can work our way backward from our final products to something else. Okay, so I gave you a couple of hints recently to kind of help you get started. We can do this if we do ozonolysis. We've already worked this out. And if we do that, we're going to end up with 2, 4, 6, 7, 8, 9, right? We end up with this as the thing that we start with. And so now the question becomes, can we convert this 6 carbon starting material into this 9 carbon product, right? If we can go from, I'm going to use dotted line here, right? If I can fill in this path, if I can make the 6 carbon starting material into the 9 carbon thing that I have down here, I can then do ozonolysis and get to my 2 desired products. Okay. Now the other hint that I gave you was that the first step adds a leaving group, and that goes back to the substitution, right? Because every substitution needs a nucleophile and a leaving group, and so the hint is that we're going to use these 6 carbons, we're going to attach a leaving group to them, and then we're going to go on and add in a nucleophile, and that's how we're going to add our carbons. Once again, you're going to want to number and label your carbons, right? So we got 6 carbons coming across here. Those most likely match up to these 6 carbons here, right? And so carbons 5 and 6 are connected by a pi bond in my starting material. Notice that the pi bond is gone, but now we have a hydrogen, an extra hydrogen in carbon-6, and we're going to have something else on carbon-5. And so it makes sense, right, if we think about this, that this is where we're going to install our leaving group. So these are the hints that I'm giving you. You're going to add a leaving group on your starting material as your first step, right? It makes sense that since we're making our sigma bond, our new sigma bond to add our 3 carbons, we're going to make that sigma bond at carbon-5. We want to add a leaving group, where do we go? At carbon-5, at C5, right? And so we need to know what reaction we can do to add a leaving group at carbon-5. And so that's, you have to go through your notes and all the things that you know about organic chemistry and figure out what reaction adds a leaving group at carbon-5. And then think about, how do I take that leaving group and turn it into additional carbons, right? Because we have to add 3 carbons. So we're adding carbons 7, 8, and 9 here. So think about what reactants we use to do that. Think about what reaction we're going to use that makes a double bond as its product, right? Because we need to have a pi bond here. And so we've talked about a couple of reactions that might do that. And this will, if we can figure those things out. So at this point, if we can figure out how to add the carbons and how to make the double bond, right? We still have a list of things to do. We need to add carbons, we need to make a double bond. And so our list has changed, right? Because we've solved one problem, then we have to figure that out from there. So hopefully that helps as you work your way forward. Go ahead and submit revisions if you want, or if you feel like you're on the right track, wait a couple days and I will definitely get back to you on your submission. Thanks.